Welcome back. So I promised you a video on how to get Docker Swarm up and running on Proxmox. Before we do that though, let's take a few minutes to stop and talk about Docker Swarm. What is Docker Swarm? Think of Docker Swarm as a lightweight Kubernetes. So if you're familiar with Proxmox, you're probably familiar with clustering and making virtual machines highly available so that if one physical host goes down, your other hosts stay up. Docker Swarm is that same clustering, but at the container level, or rather at the container engine level, rather than at your hypervisor level. There's some advantage to this in that if you can get Docker installed on something, you can get Swarm up and running. And as long as they have the same CPU architecture like x86, you can run Swarm on anything. So you could have a Swarm made up of laptops, desktops, mini PCs, whatever you wanted. Another advantage to Docker Swarm is that it is less complicated, both to set up and manage. Docker Swarm ships with Docker. There's no extra stuff you have to install or configure. Well, there's no extra stuff you have to install. The main configuration you would do in order for you to migrate from Docker to Docker Swarm is spin up additional Docker hosts, install Docker on those two additional Docker hosts, turn your main Docker host into a Docker Swarm manager, and then turn the other two Docker hosts into workers, and then join them into a cluster. After that, you have to rewrite your Docker compose files into Docker Swarm compose, which should take you like 30 minutes or, maybe like an hour per service at that. Probably less time if you pass it into one of the large language models, Gemini. All right. And you can get up and running very efficiently. I was able to move my stack from Docker to Docker Compose in like less than a day. And then I was able to rewrite that into Kubernetes in less than a day. But that's for another video. That's for later. Let's go ahead and get started. To properly get this set up, I would recommend at least 3 Proxmox hosts. On each of these 3 Proxmox hosts, you would want to install a Docker guest. And on at least one of those Proxmox hosts, you would want to install a NFS server. If you need help with any of the steps in this process, don't worry, I got you. For instance, at the bottom of this YouTube video is a link to my other video where I walk you through installing Debian and then Docker on top of Debian on Proxmox, right? So the stack is Proxmox, Debian, and Docker. If you need help installing an NFS server, don't worry, I got you. Before I release this video, I'm going to go ahead and create a video on getting NFS installed on a Linux server using OMV. OMV is an open source media server. It's an open source file server application, right? So imagine Synology, but it's based off Debian and it runs on basically anything. We set up OMV on this server right here so that the Docker hosts have shared storage and are able to communicate with that shared storage effectively. One of the main advantages of setting this up on Proxmox is if your storage is set up correctly, you can use Proxmox's built-in high availability to make the NFS highly available, making it a little bit more redundant. For instance, if you created a replicated NFS server, if something were to happen to this entire Proxmox host, the NFS server would just move from this node to this node, making the storage backend for your containers highly available. If you set things up correctly, you could even have the other Docker host move with the NFS server as well. So now, even though you've lost an entire Proxmox node right here, your services still remain up. This is of course assuming that your Proxmox nodes have enough resources for this. Designing this the right way within the constraints of your resources would be very important. The cool thing is, because Docker is running inside of Docker Swarm, you don't necessarily even need the node to move over, right? Just the storage backend. So you could have this node, as in both the hypervisor and the guest fail, and your containers are maintained running on these other two Docker guests. Another way you could set this up is instead of an NFS server, you could set up CIFS or GlusterFS or some type of other replicated storage, but that is beyond this video, right? We're trying to keep things simple here, and this is the simplest way to set this up. Step one is to install Docker. You have two options. You can either go and watch my previous video while I walk you through how to install Docker, or you can visit my GitHub repo at the bottom of this video and copy and paste my Docker install script. It should work across all distros, and it should work across Debian, Ubuntu, and CentOS based distros. Once you've installed Docker, go ahead and proceed with step two. Step two is install your NFS server. This can be setting up your Synology NAS if you have a NAS. This could be setting up your Truenas. Speaking of Truenas, if you do need to set up Truenas in order to get an NFS share out, I have a video on how to set up Truenas on Proxmox. Go ahead and watch that. The video would be at the bottom of this YouTube description. Step three of this is to configure auto mount of your NFS share on your Docker guests. All right, so this is the setup. We're going to have a NFS server with a share called Kubernetes, and we're going to mount that share automatically to each one of these Docker hosts. That way they all see the exact same file in the exact same place, just like behind me. Behind me is my Proxmox cluster, and I have 3 Docker nodes spun up on that cluster. I have DS21, DS22, and DS23. They're called DS2 because this isn't my first Docker swarm inside of the cluster, right? So we've got those nodes spun up. The next thing we're going to do is go ahead and begin the process of joining them. If you need clarification on how to get Docker installed, please look at the link in the description of this YouTube video. If you need clarification on how to get a NFS server set up and shared out, please look at the link in the description of this YouTube video. Otherwise, let's go ahead and hop on to Docker host 1 and get started. We'll start with logging into our first Docker node and installing NFS common. We can do that with an apt get install -y NFS common. I'll let that run and give it a few moments. And you want to repeat that on all 3 nodes. We're now on node 2. We run the same thing and we let it kick off. And then you repeat the same on node 3 and you let it kick off. After that, you can go back to node 1 and do a show mount -e and point it to your NFS server, and you should see the different folders you're sharing out of your NFS server. The one we're interested in is export Docker. After we've confirmed the mount is available, we should be able to do a mount command to test and confirm everything works. So if we were to do a mount -t NFS, we then point to the NFS server in the mount, and then point it to mount/Docker and hit enter and give it a few moments. When it's done, we should be able to do a df-h T, and as you can see, our mount is now available. So you just have to run this command again on all 3 nodes just to confirm that everything is working. Then we run a df-ht to confirm the mount was successful, which it was down here. Now we just add that mount option to our /CFS tab so that it auto mounts on reboot. Do a nano /CFS tab, scroll down, and then you can just paste in the mount options, which, let's go over them real quick. You enter the NFS path, you enter the local path, you enter the mount type, which is NFS4, and then you enter some mount options right here, right? Then you could do a mount-a. Now, if you do another df-ht, you should see the mount there. And on a reboot, it should automatically remount it. Now you just have to repeat that on every node. So I'm going to get that knocked out real quick. Next, we're going to turn our host 1 into our Docker Swarm manager node. Let's go ahead and get that knocked out. Back on our Docker Swarm 1 node, we do a Docker Swarm init. And that's it. That's all we need for us to get our swarm initialized. We then copy this command and we hop back on to our nodes. We're on Docker Swarm 3. We just paste that command in and it joins the swarm as a worker. And then we hop back over to Docker Swarm 2. We paste the command again and it joins the swarm as a worker. We're back on our manager node and we're going to run a Docker node ls. As you can see, it lists the 3 nodes inside of our swarm and each one of them is ready. It also lists DS1 as the leader. Now that our swarm is ready, let's go ahead and make our first container inside of the swarm. First, we're going to make a directory, mount docker nginx. Then we're going to make another directory. We're going to call this compose. Then we're going to make a file inside of compose called nginx swarm.yaml. We'll start by defining our version, which is 3.9. Then we do a services definition. Then we define our service, which is nginx. Then we'll find our image, which is nginx latest. Same with our ports. And we want to forward port 80 to 80. I went ahead and filled out the rest of this so that we could get through this a little quicker. We have our deploy section, which is where we deploy our service, which is this Docker image. We have replicas of 1, restart policy of on failure. So it restarts the container if it fails, and then the node is worker. Notice that we also have this volume section here where we pass a folder called nginx through to our container, right? That folder is where we're going to keep our persistent storage, and this volume mount is the suggested way to do shared storage with Docker containers and Docker Swarm, right? Do a NFS mount to a local folder on the Docker host, and then inside of the container, you can just pass that NFS mount through as a bind mount. After that, you go ahead and you save your file. Now it's time to deploy your file as a service inside of the Docker Swarm. First, we can do a Docker stack ls to see that there's no services listed. And then we want to deploy our service. You can do a Docker stack deploy -c, and then we point it to our file, which is compose nginx swarm.yaml. Then we're going to call this nginx stack, and it helps if you spell Docker correctly. And with that, we've just deployed that service to our stack. Now, if we were to do a Docker stack ls, you'd see we have that engine stack listed. Now let's do a Docker stack services nginx stack, and it gives us a bit more information. It shows that it's running and it is being replicated on port 80. Now let's do a stack ps to view some information about the stack, right? And let's see, state is running. There's no errors, which is good. Let's go ahead and test everything is working. We can do that by hopping over to our NFS server. And on our NFS server, we're going to do a curl. And we're going to curl port 80 on the port for Docker host 1, which should be 7780. And as you can see, we get a 403 error, which should be fine for an unconfigured nginx server. Let's see if we get the same thing at 7880, and we do, and 7980, meaning the container is up and running as expected. It's just not configured, which is fine. All right, and that is how you set up a container inside of a Docker Swarm. Once again, the main advantage here is just the multiple layers of high availability. You get container level high availability, and you also get OS level high availability with Proxmox. It's double stacking there, right? And for my testing, it seems to work well. If you lose a node, your containers just move to other worker nodes. And if you lose a Proxmox guest, either the nodes move over, or if the node doesn't move over, your containers themselves move over. So it's a pretty nice setup there. Very convenient, boys. If you enjoy this content, please hit the like button. If you'd like to see more, please subscribe. Otherwise, thank you for watching. Stay blessed and see y'all next video.